Welcome to this video about my balancing robot. First I'm going to explain a bit about the parts, the settings, the programming and the schematics. Here is the parts list. So obviously you need an O drive or an O desk. If you click this link you can buy one. You need two hoverboard motors from an old hoverboard. I've also used the metal pieces that are inside to mount the motors, you will see that later. You need an Arduino Mega, this is the main controller of the robot. An Arduino Nano to read the angles from the MPU 6050, an nRF24L01 for the robot and also one for the remote. This is paired with an Arduino Uno and a joystick. You also need a battery and a frame. Now I'm going to go over the settings for the O drive or O desk. If you have not used one before, I recommend following my Getting Started guide. These settings are based on this page, the O drive hoverboard guide. First I'm setting the pole pairs to 15 because there are 30 magnets and you need to divide by 2. I'm increasing the calibration voltage. Lowering the current range, this is not necessary but it gives you a better reading. Lowering the current control bandwidth. Entering the torque constant, for example this comes from the hoverboard guide. Setting the CPR to 90 because the Hall effect sensors give you 90 counts per revolution. I'm using 150 pulses for the calibration to get a better alignment. Need to also enter these PID values. These also come from the hoverboard guide. Set a velocity limit and set the control mode to velocity control. If you are using the latest firmware, you need to enter this command to enable the brake resistor if you are using one. After changing settings, you need to save and reboot. My project is based on these two videos from James Bruton. You can click these to watch them. I'm also using the same code for the remote, but I'm only using one joystick. I reused the remote from my cable cam project, so my pins are based on this video. There is a small mistake in this video, this is written down here. The code for the remote, the main controller, and the Arduino that handles the accelerometer, you can download here, it's a zip file. There is also a calibration file in the folder. You need to run this on the Arduino Nano that's connected to the accelerometer. You get some values out of it, and you need to replace the values in the IMU code with these. For this video I used the dual axis O-desk board, and here is the pinout for this board. This is the schematic I made for this project. So as you can see, there is an O drive for O-desk. Here's the braking resistor. This is not necessary, but you can use it. Here is the motor with the Hall effect lines and the motor wires. Here are the capacitors between the Hall effect lines and ground. These are not needed if you're using an O-desk board. I've also written that here. Here is the main controller, the Arduino Mega. Here's a potentiometer. This sets the balance point of the robot. This is the nRF24L01 for the wireless communication, and the Arduino Nano that's connected to the MPU 6050 for the angles. Now I will show you how I have wired up everything on my robot, and after that I will do a short demonstration. This is one of the hoverboard motors. This is mounted using the metal bracket that was also inside the hoverboard. These cables are from the Hall effect sensors, and these three cables are from the motor itself. These two go to the braking resistor underneath. This is not necessary because I'm using a battery, but I connected it anyway. These cables go to the second motor on this side, and this cable is for power and goes to the battery on the back. These capacitors connect the Hall effect lines to ground. These are not necessary for me because I'm using an O-desk and they're integrated, but you can still connect them, it also works. After that, those cables go to this block on the O-desk. The O-desk gets the movement commands using this serial line to the Arduino Mega. This also has the NRF24L1 for the communication with the controller. There is a second serial line that goes down to the Arduino Nano. This reads the angle from the IMU next to it and sends it to the Arduino Mega. On this side, there is a potentiometer to set the balancing point and a button to reset the ODESC if needed. The controller is very simple. It's an Arduino Uno that reads the two axes of the joystick, an NRF24L1 for the communication with the robot, and a battery pack. As you can see, the PID values for balancing are not perfect at all, but it's just a proof of concept. The link to the instructional website where you can download all the code and view the other mentioned projects will be in the description. If you have any questions, you can ask them in the comments below. Please consider subscribing and I will see you in the next video. Thanks for watching. Bye.